Robots moving in the real world have dynamic sensor data. When you are writing software for that dynamic data, your code should be able to cooperate with that sensor data. In this stage of development, your code should be able to detect different anomalies, different values, spikes, all of that in runtime to make your work easier and save a lot of time. In this video, we are going to understand the practices you can utilize when you are working with ROS2, how to tune your software in real time and observe different sets of data. I have created a package, data parameters, and there is a camera node added into the CMake list. What we will be doing is subscribing the Kitty data, and we are going to produce an output Canny left. Just to get the data, apply Canny filter on its vision and then publish it. Let's start by giving a lower threshold and a higher threshold. Then the aperture to have all the required parameters for Canny edge detector. Let's create two objects of matte and convert our current image into grayscale by this line and then applying the parameters of Canny edge detector. Once this is done, we are going to simply create another matte object and convert back into BGR so we can see in RViz. Putting this into a message that ROS can easily understand, and we are going to simply publish it with the specific header. Let's compile this and make sure you already have that Kitty dataset running system that I have already explained in dataset ROS2 video earlier. It is going to be running with ROS2 run ROS2 Kitty package, Kitty publisher package. We are also going to visualize it in RViz too. Let's run the data and run RViz. Here we are going to visualize the data, starting with color, left, and visualize it. This is what the data is giving us. Now let's run the node that we have, ROS2 run data parameters, and it was camera node. I have to restart the data again and the node is working. I have to add the output of the node, Canny, left, and image. So this is the Canny edge detector algorithm applied on the current image. We can observe this. You can now search about Canny edge detector, what it is required and why it is utilized, but it provides very good edge detections that you can utilize to get the road, get the sidewalks and all of that. You can easily segment them. Now to have different output understanding and finding the best values and parameters for these lower and upper bounds of Canny, I have to make changes here. Let's say I change it to this thing, this value, and then I again have to stop this and perform call can build in source and then run the node again. This is a process that is time taking and it is not that useful when you are working on multiple sensors and you have to find good parameters for each single sensor. I have to rerun the data to visualize and some changes which we can simply observe, but let's take another approach. Now we are going to be using Kitty dataset with 3D LiDAR and camera data. There are algorithms to process sensor data which contains parameters. So these parameters are going to be tuned or changed values in real time to see the effect and find out the best values in our specific dataset, which is going to save a lot of time. Let's see. Parameters only require declaration and utilization of that parameter. So simply defining that we have declared a parameter named as lower threshold, default value is 100, and then there is another parameter upper threshold, default value 200, and simply we are going to then move on to these values. I'm going to simply replace these values with get parameter lower threshold as a double, and for the upper one obviously I'll use the upper threshold. So this is the simple addition that you have to do. Declare parameter and get the parameter, and that's it. Now let's try to make this work. Compile this. One more thing that we will be needing now is RQT graph. ROS2 run RQT GUI RQT. Press enter. It is going to come up. It totally based on what you have previously opened. So I'll start from the scratch. Plugins, configuration, dynamic reconfigure. This is the most important thing that you will be looking forward to when you are working with parameters. Everything is compiled. Let's run the data. RViz is running. Stop this node and rerun the node and open RViz. Let's enable the data. And now with RQT GUI, I'm going to first refresh. We have lower threshold and we have upper threshold. These two parameters are now available to us. Let me change upper threshold and lower threshold. You can see, you can live understand the changes that you are doing with the parameters, and this saves a lot of time. So obviously this is very undesirable. Let's make it 150. I have to rerun the data. 150 and 155. So noise is reduced. I'll keep on moving. Let's go to 140 and 145. This is the understanding that I wanted you to build, that you can simply change in the values and you can find out the best parameters for it. Obviously this is not desirable for now, but you can easily observe the line dividers that we can see in the image can be detected and segmented, and you can simply craft out this road only, not this whole area that is needed, and you can do that with parameters as well. So this is something that you can do. Let's try a simple code. There are a few changes that I have made. I have introduced another parameter of X to just look at things, just to give you an understanding of how you can control a lot of things with parameters. Starting with the data, let's run this data. In RQT, I'm going to go camera node and refresh it. So 0 to 100, I can select or crop out a specific area in the frame. Let me do it 300. So I can crop the image as well, change the values of these upper and lower thresholds of the Canny edge detector on the go, which is very powerful thing that we can do with the parameters and find out basically the best parameters for our application that we are working on, save a lot of time. This is something very important. And let me give you one more example with the LiDAR data so things can get more clear to you. Let's run the data and visualize the LiDAR that we have on this point cloud. We have to fix the frame to base link so we can visualize the actual LiDAR. Let's take a look onto this node, which is applying a voxel grid, and it also gives us the ability to shrink or expand the view of our interest, meaning region of interest, with the X, Y, Z parameters, minimum and maximum. Leaf size is just to increase or decrease the density of the point cloud. So this code is going to make sense when we visualize it. This data is running. Let's run this node, and in RQT GUI, I'm going to go plugins, dynamic reconfigure, and LiDAR node. Refresh this. We might need to run this data again and again. Let me fix this. One of the most important thing is the leaf size when processing the point cloud. I'll open this point cloud. I will not view this actual point cloud. Instead, I'll just visualize the processed point cloud. So you can see points are really less. We can increase those points with this parameter 0.01. The density of the points increases and we can easily observe them. Now coming to the next observation that we can build around with the parameters is increase and decrease in the leaf size, increase and decrease in the points is happening in the live transmission. We can observe them. So we are going to keep it very low so we can observe the difference in the things that we are going to apply next. For example, X, Y, Z minimum values. Start the X from 0 and go it to the 10 till this point. The negative side should be minus 10. So we have cropped in the X-axis. Coming to the Y value, I'll rerun the data. Coming for the Y value, let's understand the graph. I'll set it to again 10 and minus 10. So we can easily segment things on the go and change the values and understand what could be required next. Z is not going to affect much, but in X and Y segmentation, we can understand how much area that we are interested in, what should be the values for segmenting the road. Let's say if this is not we want, we can go into the Y and we could say 5. It is going to keep on rejecting the points that we don't need. And this is quite easier when we are doing like this way. So simple road can be easily extracted. The next is changing of its leaf size. We can easily deduct the leaf size and get the points that we want, some less points for easier processing. But the main thing is you can do it very fast as compared to making change in the parameters in the files and doing it step by step and then compiling it wastes a lot of time, but this saves a lot of your time. Having good habits when writing software for your robot is going to save a lot of your time, and it makes you a good developer, desirable by the team and the whole environment that you are working on. So involving practices that saves not only your time and other people's time, give them ideas and make your software easily reusable, and finding values for your algorithms, the parameters, to be very specific for a very specialized case, makes your work of good quality. And the next time when you are visiting your work or someone else, they are going to look at the reason why you selected these values and how the documentation you provide will defend your work.